All right, so in this video, we're going to be solving for the values of x in this exponential equation. So how do we tackle this question? Because I'm pretty sure a lot of people would like to ask how to start. So in my own opinion, what we're going to be doing is that for sure we are using algebra and not logarithms. So I'm going to have to rewrite this number right here, which is 8, to have a base of 2, because we can do that, right? So a is the same as 2 times 2 times 2, which is the same as 2 cubed. And there is a power of x, so I'm going to have to keep the power. Then next we have plus 27 could also be written in terms of base 3, which is the same as 3 times 3 times 3. That means we have 3 to the power 3. Then there is a power of x. I put it down like that. Then all divided by this right here. Now 12, how can we rewrite 12 in such a way that we have a base of 2? Well, it looks kind of challenging, but don't worry, this is what I'm going to have to do it. So I'm going to write 12 as 2 times 6, because for sure I know that we have 2 right here, and at least I have one of the 2, so there's no problem with that. Then I open a parenthesis, there is a power of x, I put it down, then plus 18 is also the same as 6 times 3. Again, I have one of the 3's right here, so you see it is pretty interesting, right? Then we have a power of x. I'm gonna have to put it down like that, and this is equal to 7 divided by 6. Cool. Now over here, you notice that we have 2 to the power 3 to the power x. We can just switch their positions, because the positions of their powers, we can just go ahead and switch them. So we can have 2 to the power x or to the power 3. Why are we doing this though? We are doing this because we want something to represent 2 to the power x, as simple as that. And the same thing applies to this right here. We can just switch the positions. So I'm gonna switch the x and then the 3 so that it will look something like this. Cool. Then all divided by the denominator side, we can also distribute the power, all right? Because if we have something like, let's just say a, let me use a different color for this. Let's just say we have a to the power, a times b, or to the power, let's just say x. This means that we can have a to the power x times b to the power x. And this is the property that I'm gonna apply right here, all right? So here we can have 2 to the power x, then times 6 to the power x. Then next we have plus, we're also distributing this right here. We can have 6 to the power x times 3 to the power x. And this is equal to, for the right hand side, there's no problem with that. So we're going to be keeping them like that, right? We're going to be keeping the fraction like that. So over here, what I'm going to do is that, you notice that we have 6 right here, and 6 is the same as 3 times 2. So if the 6 is having a power of x, this is how we are going to be getting the 6, right? And then we're going to be expressing this as 3 to the power x times 2 to the power x, which could come right here, all right? So that means we're going to be getting the equation to be 2 to the power x, or to the power 3, plus what we have right there, all divided by 2 to the power x, then times 6, which is the whole of this. So we have, but I'll write the 2 to the power x first, then times 3 to the power x, then plus another 6 right here, which is the same as 2 to the power x times 3 to the power x times 3 to the power x. And the right hand side, like I said before, it is always 7 divided by 6. And now you notice that the denominator side is pretty interesting. So I'm keeping the numerator side, which is 2 to the power x to the power 3, then plus 3 to the power x, or to the power 3, divided by, now right here the bases are the same, so we can just write one of them and then sum the powers. And when we do that, we are getting 2 to the power 2x, which could be written as x times 2, all right? Because 2 to the power 2x could be written as 2 to the power x, or to the power 2, because we take this one to multiply this, and that is possible. Cool. So now this is what we are getting, then times 3 to the power x, which is this right here. Then next we have the additional sign, and then over here I'm keeping the 2 to the power x, and then multiply these two numbers. Of course, we have the same basis, so I'm gonna have to write one of them and then add the powers, which is also going to be 3 to the power x to the power 2. All right, and then the right hand side is going to be 7 divided by 6. And now I don't want us to worry ourselves anymore. I'm just going to do substitution. So I'm going to have to say let maybe a to be equal to 2 to the power x, and then b to be equal to 3 to the power x. So that means wherever I see 2 to the power x, I'm going to put a. Yeah, so let's go. Now we are going to have a to the power 3, then plus this right here is also b, so we're going to be getting b to the power 3, all divided by, now we have a squared times b, because this is b, right? And then we have plus this right here is also a, and this is b, so we're going to be getting a times b squared, and this is equal to 7 divided by 6. Now at this moment, you notice that we have addition of 2 cubes, so we can just use algebraic identities for this. So a cube plus b cube could be expressed as a plus b times a squared minus ab plus b squared, right? That is what we have. Then divided by, now over here you notice that we have a here, b here, b here. So precisely we can just factor out b, ab rather. So when we do that, we have ab out, then we are left with one of the x right here, so I put it down, then plus we are left with one of the b's right here. This is what we have, and the right hand side, no problem with that, we are keeping it. Now you notice that this right here will cancel out this, and we are left with a squared minus ab plus b squared, all divided by ab is equal to 7 divided by 6. And from here we have to just go ahead and then cross multiply. So this 6 will cross and multiply the numerators out of the first fraction, and then ab will cross and multiply the 7. So when 6 cross and multiply the numerators out of the first fraction, we're going to be getting 6 times a squared, which is this, then minus 6ab, then plus 6b squared. And this is equal to 7 will multiply the ab, and we are getting 7ab. Cool. And now it looks like we have quadratic equations. So what I would like to do is that I will equate everything to 0, so that it will look like this: a squared minus 6ab. Now if we subtract 7ab from both sides, we're going to be getting negative 7ab right here, then plus 6b squared, and this is equal to 0. All right, then we simplify this further because we can do that. Now we have 6a squared minus, now the whole of this will give us negative 13ab. So negative 13ab then plus 6b squared is equal to 0. And this is where the game is really getting interesting. So what I'm going to do is that since we have two variables, I'm going to see one of them as a variable and then see the other one as a constant. So look at the nature of this equation. I would like to see the a as a variable and then the b as constant. So let me highlight the a for you to see that this is what I'm treating as a variable, and then the b will be a constant. So now it is obvious that we have a quadratic equation. So in solving quadratic equations, we have factorization method, we have using the quadratic formula, and then we have completing the squares. But precisely I'm going to be using factorization because that is possible. So what I'm going to do is that I'm just going to take this coefficient and then multiply by this constant. So 6 times 6b squared is giving me 36b squared. Then from here, I look at two factors that their product will give me this value, but their sum will give me negative 13a. And what are these factors? Now, it looks like this number right here is going to help us because I know for sure that 9 times 4 will give me positive 36. All right, so 9 times 4 is giving me positive 36, but when I add them, I should get negative 13. So that means to achieve this negative 13, I'm just going to put negative in front of these two factors. Now we are getting this negative 13, but we are not getting this 36b squared. So what I'm going to do is that I'm just going to put b here and then b here, so that when we multiply them, we are getting this one, and when we add them, we are getting negative 13b. So you see, this is really simple. So now the equation becomes 6a squared minus 9ba, because a is the variable. So let me go ahead and then highlight that real quick. So a is the variable. Then next we are getting negative 4ba, where a is also the variable, and then we are left with positive 6b squared, and this is for sure equal to 0. Now we can just go ahead and then factor out the common terms right here. 3 can go into 6 and 9, so I'm gonna have to factor out 3, and then we have a here, so we're gonna factor out a as well. Then we are left with, what times 3a will give us 6a squared? That is 2a. Then what times 3a will give me negative 9ba? That is for sure negative 3b. All right. For these two remaining terms right here, I'm also going to factor out negative 2b, because I know that for sure if negative 2b multiplies to a, we are getting negative 4ab. So we're going to be getting 2a right here. All right. Then minus, what times negative 2b will give me positive 6b squared? That is pretty easy, negative 3b. Then this is equal to 0. Then from here, we go ahead and then factor out the terms in the parentheses, because they are the same, right? So I'm going to have to factor out 2a minus 3b, and then we are left with 3a minus 2b, and this is equal to 0. Now, for now, we can form two equations. The first one is 2a minus 3b is equal to 0, or the second one is this right here, 3a minus 2b is also 0. Then from the first equation, you'll know that we can just transpose this term right here. So we're going to be getting 2a is equal to 3b. That is when we add 3b on both sides. Now, remember our aim is to solve for x, and this is what we have right now. So I can just express this one in a fraction form. I'm going ahead to divide both sides by 2b, and the reason is that I just want this and this to cancel out, and I'm left with a over b is equal to this, and this will go, then we have 3 over 2. So now we know a over b. We can also go ahead and then do the exact same thing for this equation right here. And if we do that, we're going to be getting 3a, then I transpose the negative term, and I'm getting positive 2b. Then again, I'm going to have to divide both sides by 3b like I did in the other one, 3b like that, and you notice that this and this will go. So this and this one will go, and then we are left with a over b, which is equal to, the b's will also cancel each other, then we have 2 over 3, and that is it. That is it. But like I said, this is not what we are interested in. We are interested in the value of x. So when we have a over b to be equal to the whole of this, it means that we said a to be equal to this right here. Let me show you real quick. We said a is equal to this, and then b is equal to this right here. So that means we're going to be getting a, which is now 2 to the power x, divided by b, which is 3 to the power x, is equal to this fraction right here, which is 3/2. All right. Now, we can just go ahead and then express this one this way. We have 2 over 3 all to the power x, because that is true. The powers are the same. So we can just go ahead and then write it this way. Okay. Now, this is still equal to 3/2. Now, you notice that here we have 2 as numerator, but here 2 is a denominator. So we have to reciprocate this fraction in order for us to get what is here. And to do that, for sure, we're going to be getting 2 divided by 3 to the power x is equal to, now once we reciprocate the fraction, the power changes, okay? It is positive right now, it is positive 1. If we reciprocate it, it becomes 2 over 3, where the power is going to be negative. And for sure, the bases are the same, therefore the powers are the same. So we can have x to be equal to -1 as one of the solutions, okay? Now, how about when a over b is equal to this? So when a over b is equal to 2/3, oh yeah, 2/3 like this, we're going to be getting a, which is 2 to the power x, over b, which is 3 to the power x, is equal to 2 over 3. And now this is also the same as 2 divided by 3, all to the power x is equal to 2 divided by 3. Now you notice that the bases are the same, therefore the powers are also the same. But it looks like this right here do not have a power, but actually there is, because this is a power of 1, right? So the bases are the same, therefore the powers are also the same. And this is the other solution to the problem. So two solutions: x is equal to +1 and x is equal to -1. I hope that you found the video useful. If you did, go ahead and then smash the like button, subscribe to my channel for more, share, and I will see you again on the next video. Thanks for watching.